So welcome to Module 3, and in here we will be talking about torsion. Consider a bar to be rigidly attached at one end and twisted at the other end by a torque or twisting moment T equivalent to force times distance. So the torque is equal to force times distance, which is applied perpendicular to the axis of the bar as shown in the figure. Such a bar is said to be in torsion. So what will happen here in torsion is the member subjected to torsion ay pumipilipit, no? So if we imagine this as the initial condition before the torque is applied, no? So after the torque is applied, magkakaroon siya ng deformation, and that deformation here is this theta. And later, pag-uusapan natin yung deformation na to. And we will talk about the torsional shearing stress. For the solid or hollow circular shaft subjected to twisting moment T, the torsional shearing stress tau at a distance rho at the center of the shaft is given by the equation tau is equal to T rho over J, wherein kung ang pinag-uusapan natin ay kung gusto nating kunin yung shear stress at this point here, and this distance from the center is rho. So this rho here is the distance from the center of the shaft. Now, if we are going to have the maximum shearing stress, the farther the distance from the center, the larger the shearing stress. So ibig sabihin, the maximum shearing stress is when this rho is equal to the radius of the shaft. So we have the maximum shearing stress is equal to the torque T multiplied by the radius over the J, wherein this J here is the polar moment of inertia of the section and R is the outer radius. Now for solid circular shaft, we have the maximum shearing stress is equal to TR over J. So for the circle, we have the polar moment of inertia is equal to pi d to the fourth over 32. And we know that the radius is just half of the diameter. So we substitute these values in our equation, and we have the maximum shearing stress is equal to the torsion multiplied by diameter over 2, which is the radius, over the polar moment of inertia pi d to the fourth over 32. Now simplifying this, and we would have Td over 2 multiplied by 32 over pi d to the fourth. So we would have the maximum shearing stress is equal to 32 divided by 2, that is 16. And we have here T, CD, makakancel yung isa, and we have here cube sa denominator, and we would have pi d cube. So this is the formula for the maximum shearing stress on the solid circular shaft. How about if we have a hollow circular shaft? So using the same formula, we have the maximum shearing stress is equal to TR over J. But in hollow circular shaft, the polar moment of inertia is equal to pi over 32 multiplied by d to the fourth minus d to the fourth. And of course, here, the radius is d over 2. And we have here the maximum shearing stress is equal to T multiplied by the diameter over 2, which is equal to the radius, over the polar moment of inertia, that is pi over 32 multiplied by d to the fourth minus d to the fourth. So, simplifying this, and we would have Td over 2 multiplied by, of course, the reciprocal, that is 32 over pi multiplied by d to the fourth minus d to the fourth. And we have the formula for the maximum shearing stress would be 32 divided by 2, so that is 16 Td over pi diameter to the fourth minus the interior diameter to the fourth. And this would be the formula for the hollow circular shaft. Topic 3, the angle of twist. The angle theta through which the bar length L will twist is theta is equal to TL over JG. Panahon ang theta mo ay true love ni Jano Gigs. No? So where T is the torque in Newton mm, L is the length of the shaft in mm, the G is the shear modulus in megapascal, and J is the polar moment of inertia in mm to the fourth. D, capital D, and the lowercase d are the diameter in mm, and R is the radius in mm. And since kung mag-unit analysis tayo dito, no, so for theta is equal to the T, which is the torsion, the torque, which is in Newton mm, to be multiplied by the length, which is expressed in mm, over the J is the polar moment of inertia, mm to the fourth, and the modulus of rigidity is in megapascal, and that megapascal is Newton per mm square. So we would have here Newton cancelled out. Itong 4 divided by 2 is 2, and mm times mm is mm square. So all of the units would be cancelled out, meaning this theta here is unitless. Since this is unitless, the resulting deformation here is in radian. So in order for us to convert this in degrees, so what we are going to do is, since we have here the value in, so we have here the value of the angle in radian, what we are going to do is to convert this, and we know that pi radian is equal to 180 degrees, and the radian would be cancelled, and your angle in this case would be in degrees na. Topic 4, power transmitted by the shaft. A shaft rotating with a constant angular velocity omega in radians per second is being acted by a twisting moment T. The power transmitted by the shaft is given in the equation. P is equal to the torque multiplied by the angular velocity, and this is also equal to 2 pi multiplied by the torque and multiplied by the frequency. F is the number of revolutions per second, and P is the power which is expressed in watts.